Hi everyone, in this video we'll be exploring different ways in which we could represent a particular graph. So there are a couple of ways in which we can represent a graph. So two of the ways are adjacency matrix and another way is adjacency list. Okay, so we'll be understanding both the techniques. So we'll be seeing which one we should use instead of the other one. Okay, so let us first explore adjacency matrix. Okay, adjacency matrix. So we'll be exploring this technique first, and later on we will see why this might not be helpful in the later cases. Okay, so let us quickly see. So we have this particular graph. Okay, we have five vertices. So one, two, three, four, five. So let's take a variable n, which essentially stores the number of vertices. So if n is five, that means we have five vertices. Okay, so in adjacency matrix, what we usually do is we consider a matrix of size n cross n, n cross n, where n is nothing but the number of vertices. Okay, so we will take a matrix of size n cross n, that is 5 cross 5. Okay, so let us quickly draw that. 1, 2, 3, 4 and 5, and we have 5 columns, right? And what we can do is we could index them based on one indexing. So if instead of 0 based indexing, we will be using 1 based indexing. So the starting will be 1, 2, 3, 4, 5. So these indices indicate the node. Okay, so 1 is nothing but the first node, 2 is nothing but the second node, 3 is nothing but the third node. In the similar way, so these indices indicates these nodes. Okay, 3, 4, 5. Now how we are representing this particular graph is, let's say we have an edge between 1 and 2. So if from this we can say this is like a undirected graph, right? Undirected graph. So this is like the undirected graph. That means an edge between two vertices indicates that that edge is bidirectional. That is, from 1 to 2, we can go from 1 to 2 as well as from 2 to 1, right? That means it's bidirectional. Now, whenever we have an edge between two vertices, we will mark that particular cell as 1. So what I essentially mean is, so if we have an edge between 1 and 2, so we'll be moving to the cell that corresponds to 1 and 2. So we have 1 here and 2 here. So this cell will be marked as 1. In the similar way, since this is bidirectional, from 2 to 1, also we have an edge. So from 2 to 1, we'll have one edge. So 1 to 3 and 3 to 1, right? So from 1 to 3, 3 to 1. Okay. The similar way, 2 to 3, 2 to 1, 2 to 4. 2 to 3, 2 to 1 is already marked, 2 to 4 is not marked. Okay. Now since we have an edge between 2 to 3, we'll have an edge between 3 to 2 as well. In the similar, we will have an edge between 4 to 2 as well. Okay. Now from 3 to 1 we have an edge, so it is already marked. From 3 to 2 we have an edge which is already marked. We have an edge between 3 to 4 and 4 to 3. So let us mark that. So from 3 to 4 we have an edge, and from 4 to 3 we have an edge. Okay. Now, so for 1, 2 and 3, I guess it's completed. And for 4, if we see, we have an edge between 4 to 3 and 4 to 2. So for 4 to 3 and 4 to 2, it is completed. And we have an edge between 4 to 5 and 5 to 4. So let us mark that. So 4 to 5, we have an edge. 5 to 4 also, we have an edge, since it is bidirectional. Now from 2, we have 2 to 5 and 5 to 2, right? So 2 to 5, we have an edge, and we have an edge between 5 to 2, right? Now this is how a adjacency matrix will look like. So we can mark remaining all as empty. It might be a number like -1, -2, any number, which will mean that there is no edge between those particular vertices. Okay. Now this is one way in which we can represent this particular graph, where the indices will indicate the nodes, and if we have an edge between two nodes, that means we will be marking that particular cell as 1. Now, when this might fail, so this will be fail for large n. So for large n, this particular will fail because it will occupy a large amount of space, right? So let's say we have some 10,000 vertices or 1 million vertices. So this space, this would occupy, that is 1 million into 1 million times, right? So the space would be 1 million into 1 million times. So that is not an optimum one, right? So the next thing which we can use is adjacency list. So in our further videos as well, we'll be using adjacency list in order to represent a graph. So it is pretty simple. It is similar to adjacency matrix, but instead of using matrix, we'll be using array of lists. So let me just uh, quickly draw that. So let me first draw this graph. So we have 1, 2, 3, 4, and 5, right? And we had an edge between 3 to 2 as well. So this is like undirected graph. Okay. So the other way of representing this particular graph is using an array of list. So array of array. So essentially array of list or list of list both mean the same. So what I'm trying to say is, so let us take this particular array. Okay. So we have this array. So this will be initialized as so no initialization will be done in terms of Python, but in other languages we generally initialize as, let's say in C++ we initialize as vector of int or array of vectors. Okay. So here what we'll have is each we will have an array which will contain listed. Okay. So it will be something like array of lists. So in this way, so we'll have something like this. Okay. So this will be size of number of vertices. So something like this. So adjacency list will look something like this. It is nothing but list of lists. Okay. Now here each index will indicate the vertex. So we'll have one based indexing. So let us consider one based indexing. 1, 2, 3, 4, and 5. So here each indicates that is each vertex indicates this index, right? So vertex 1 indicates this particular index 1, vertex 2 corresponds to this particular index 2. In the similar way, 3, 4, and 5. Okay. Now let's say we have an edge between 1 and 2, right? Since this is like array of lists, that is list of lists, so the 1 will contain, so in the similar way, let me draw these arrows. So this indicates we'll have this particular list. Okay. So we have an edge between 1 to 2 and 2 to 1. So for 1, we'll append 2 as an edge. So this means that if this particular list contains 2, this means that there is an edge between 1 and 2. Okay. And there is an edge between 2 and 1 as well. So let me mark that. So we are just appending that particular node value, right? Now we have an edge between 1 to 3 as well. So 3 will be appended to this list, and for 3, 1 will be appended. In a similar way, for 2, we have an edge between 2 to 1, 2 to 3, 2 to 4, and 2 to 5. So let us mark that. So we'll have 2 to 3, 2 to 4, 2 to 5. 2 to 3, 2 to 4, and 2 to 5. Right? The similar way, from 3 we have 3 to 2, 4 to 2, 5 to 2. 3 to 2, 4 to 2, 5 to 2. Now once 2 is completed, let's move to 3. For 3, we have from 3 to 1, 3 to 2, that is already marked. From 3 to 4, we have an edge. From 4 to 3 also we have an edge. So let us quickly mark that 3 to 4 and 4 to 3, right? In the similar way, we have for 1 from 4 to 3, 4 to 2, and 4 to 5. So 4 to 2 is completed, 4 to 3 is completed, 4 to 5 is not done. So let us mark that. So for 4, we have 5 as an edge. So similarly for 5 also we'll have 4 as an edge. Now from 5 we have 5 to 4, which is already marked, 5 to 2, which is already marked. So for remaining also everything is marked. So this will be our adjacency list, right? So what we are doing is, initially we will create this particular adjacency list, which will be essentially a list of lists. Okay. And each index in this particular list will represent the node value. Okay. And if you have an edge between two vertices, so at this particular vertex we will append the vertex that we have an edge, right? So if we have an edge between 1 and 2, so at this particular 1 index we will append 2 to that particular list. So this is how an adjacency list will look like, and this won't occupy much space when compared to adjacency matrix, because here we are just storing the edges itself, right? So if we see here, we have this abundant space, right? So this abundant space will be omitted in terms of this particular adjacency list, right? So these were like the two ways in which we could represent our graph. So that is adjacency matrix and adjacency list. So it is always suggested that you use adjacency list, but for smaller values of n, you can even take the adjacency matrix as well. So it's completely your choice. But for the forthcoming videos, we will be using adjacency list in order to represent a graph. Okay. So that's all for this video, guys. I hope you understood both the approaches of representing a graph. Let's meet in some other video. Till then, keep learning, keep hustling. Thank you.